So I will explain a bit what's Debian and what's a Debian port, why I want to create a port for RISC-V, and the goals for the project, the plans, and the progress and the expected benefits for the community. So Debian is a community of individuals, mostly volunteers. There's no overall control by companies, as in the case of Red Hat or Canonical with Ubuntu or other Linux projects. There were volunteers and individuals who care about free software, open source software, with the goal to create a full comprehensive operating system, a large set of software packages, coherent, integrated, and creating stable releases every 2 years or so, and keeping software freedom as a core goal with the social contract and the free software guideline documents, for example. As a Linux distribution, it was started by Ian Murdoch in '93, so soon after the first Linux releases, Linux kernel releases. He passed away sadly last year, but still continues to be one of the major families and flavors of Linux distributions, with the deb packages and so on. There are more than 22,000 source packages in 2016, and it's the basis of many derivatives or downstreams, like Ubuntu is the best known derivative, Raspbian for Raspberry Pi, SteamOS, and most of these downstreams use Debian packages unmodified. And also support, apart from the Linux kernel, it also supports FreeBSD and GNU hard kernels. A Debian port is, in short, is a computer architecture, kernel, and libc ABI. Most of the ports use Linux and libc, but there are also ports for using FreeBSD kernel with libc and GNU hard, and experimental ports with Linux and the Musel library, for example. The examples of ports are the x86 ones, which for 64 bits is called AMD64, and also several flavors of MIPS, ARM, PowerPC, and others that you might recognize like Alpha, Super 8, Spark, and so on. There are 3 kinds of ports mainly. So some of them are the officially supported ones, so are the ones which are part of the official Debian releases. Unofficial or unsupported are the ones which are hosted in Debian infrastructure, but they are not part of the stable releases. And some of them are outside. Arguably, like Raspbian is mostly a recompilation for Raspberry Pi specific hardware, which for historical reasons is not completely integrated in Debian, but there are still close collaborations. The criteria to be officially supported in stable releases is to be able to build most of the archive, 95 or 98% of the archive, have enough people behind that, have hardware available for build daemons and so on. It has to be managed by Debian system administrators and so on, so there are a series of requirements. In return, when they are accepted as stable release ports, they have security support for 3 to 5 years that it takes the release cycle. And so all of Debian feels responsible for these ports in a way. And unofficial or unsupported are when they don't qualify for some reason. There are not enough people working on them, the hardware is not available, maybe there are missing compilers for Java or Haskell, so thousands of packages of the archive cannot compile. But still they are hosted in the infrastructure, so they can be downloaded, and after the system is installed, they are upgraded using Debian.org servers, cryptographically signed, secure installations, and so on. And the best part is that when the maintainers of the software packages, like your favorite media players or browsers, upload a new version, it is available for all of the ports at the same time, or in a few days or so. So why a Debian port for RISC-V? It's mostly for personal reasons, so I'm not sponsored by anybody. And I'm interested in Debian and RISC-V. I'm already a Debian developer, and I like RISC-V design and goals. I think that they are a good fit technically and philosophically, both projects in a way. And I would like to help to improve and see both grow. Also because I was working in the OpenRISC port for Debian in the past, and I had lots of fun, so I want to repeat that. And ultimately, I would like to get hardware based on RISC-V and run Debian on it. So I have to start somewhere, right? And related the technical and philosophical reasons, Debian already welcomes many ports, and many ports from the family, for example, from the paper of RISC-V genealogy, like MIPS, PowerPC, alphas, and so on. Some of the goals are compatible, or the methods that the projects use are compatible, like aiming for openness and freedom, based on in the free and open source software ecosystem, GNU toolchain, among others, also like LLVM, Linux, and another good reason is that both projects strive for good technical solutions instead of, for example, quarterly profit, for example. So there are no constraints on that regard. And so the goals of these projects is basically have Debian ready to install and run on RISC-V-based systems when they are available, and to be fully integrated with Debian infrastructure. So it's not a one-shot to try to compile all of Debian today and that's it. It's mostly a job of integrating it with the current project. So the plan is to bootstrap and create a basic disk image, and that it's a basic image that then can be used to bootstrap the rest of Debian. Then work to integrate it as an unofficial port. So for that, it's mostly to prepare infrastructure, like build daemons and communications between different parts of Debian in the backend, and documentation, organize people, or also import the bootstrap set and rebootstrap it, like built in a sane and like clean environment and so on. And then start to build all of the 22,000 packages of the distribution. And in the future, if hardware is available, people are interested and so on, to create, to promote it to an official port, maybe in a few years. Software-wise, the targets are to use the Linux kernel and libc, and GNU libc and userland, because all of the official well-supported ports of Debian use these as a base. With the hardware, the target is 64-bit and little endian, because as we saw yesterday, there is no support for big endian, for example. It's not well developed and so on. And there are hardware planned for years, like low risk already, which plan to target this hardware flavor. And in general, 64-bit and little endian have been the focus for general purpose for several years. For example, PowerPC created a little endian version after creating the big endian first. And other variants of RISC-V, like I think that 128 bits is not realistic really at this time. 32 bits is not as well supported in RISC-V community, I think. But also in Debian, there are already problems to compile big packages like Firefox or Chromium or LibreOffice in 32 bits because the machines run out of memory, and there are all sorts of problems which are only going to get worse as the software continues to expand to use all available space. And embedded and Internet of Things and so on, all of these areas mostly are interested in minimalistic systems, not like Debian, which is a bit more comprehensive, trying to include many features and dependencies and so on. So about the progress, I really started almost 2 years ago, like starting with the idea and so on. But I had frequent I post frequently because I was waiting sometimes for the specs to be ready, for the toolchain to be integrated upstream, which didn't happen yet, and it's not essential, but it's very inconvenient to manage. I was waiting sometimes for QEMU to match the specs or have features that they are not ready yet, and also because of other problems, I had to stop working on that for personal problems, even to stop working on that for a few months. So I was checking from time to time what was the progress and trying to make some progress of my own. But essentially, as of March, I think this year, I built 300 or 400 essential packages of what are essential packages for Debian bootstrapping, which are some very basic, like the GNU core utils, make, bash, wget, flex, etc. Some of them are more large or complex, like media codecs for PNG, JPEG, OGG. Some are more complex packages like dpackage or apt, which are some of the bases of Debian. So if dpackage is not present, you cannot call it a Debian system, really. And things like OpenSSL or Nano Editor, for example, they are a bit more complex because they use the courses library and courses. And also I got some X-Windows packages. I think that they are all part of the protocol, not something fancy like showing graphics, but still. And many of these 300 or 400 are not interesting packages per se, but they are dependencies like XML libraries needed for other packages. I build them mostly by cross-compiling, but some of them, like Perl, they resisted cross-compiling, so I had to compile natively inside QEMU for a few hours or days. And some of them I had to build several times because in Debian especially, they come tied with different dependencies, circular dependencies, so you have to untie them and compile several times until you get the final outcome. And some of them I just rebuilt it several times to test different things, like I cross-compiled the package, but then compiled inside the emulator. Most of the packages were built with no modifications whatsoever. Part of that is because of previous Debian ports. That's why I think that it's a good match also, because many patches already support oddball systems. So since RISC-V is not so odd compared to others, the packages already support them without modifications. Most of the other work is untying these circular dependencies. And some of them, like memory allocators, for example, they need specific support for RISC-V, like word sizes and so on, that they didn't. So they don't have support for that yet, like JMalloc, I think that it's the name of one of them. And so I build them, but do they really work? And the answer is mostly yes. You can boot the system and move around and use common tools like mount, grep, and find, and all that. You can do that with the images provided by RISC-V, so that's not a big advance. But I think that one advance compared to the image from RISC-V is that I could compile new packages, for example. With my image, I could compile the package, for example, again. So I think that it's an advance. And I found many problems in the way. So for example, I found problems with file locking. The package is working basically, but cannot get logs from the kernel to log the database. So it cannot really install any new packages in a conventional way. And so I submitted patches for that. QEMU and Spike don't support network, so I couldn't test the packages like wget that need the network. And with the API changes, especially the userland changes recently, I think that all of the work that I was doing is not working anymore if I try to use the modern version of the tool, so I will probably have to start from scratch. How the RISC community can help? I think that basically it will be to stabilize the specs and API, upstream support that many people are asking for, and fixes to the kernel and API, and what Aaron Thomas said about already in this workshop and in the previous one about building the RISC software ecosystem. And the benefits are, by the pod being started, we are finding problems in the stack and submitting patches and so on. People from Debian camp are learning about RISC-V, so I think that it's positive for RISC-V. When software comes available, people, I think that they are likely to be more likely to pay attention to RISC-V, because I think that one of the reasons for Raspberry Pi to be so popular is that there is a lot of software available from Debian and other distributions. And having a large collection of software is interesting. For example, ARM test with Debian regularly changes about in their macro architecture sometimes, or do benchmarks and so on. And it's important to have lots of software available to do as a real benchmark of real software instead of synthetic benchmarks. And you can also use, when it's ready, hopefully, to install it in your RISC-V system, so you can then install software with a line, apt-get install awesome package, or upgrade your system and keep it up to date, and so on. And even cross-build is your development for the ecosystem. So you can install a cross-compiler and cross-compile your binaries to run in the RISC-V system as a target. And well, I would like to thank especially Kurt Kevil, who helped me a lot to get here, and encouragement and so on. Christian Svensson for starting the OpenRISC port and getting me hooked into this Debian ports thing. But Mark is a hosting provider for hosting the hardware, and my family for support, especially for this travel as well. And to Debian contributors and to RISC-V, because it's an amazing community and very fun and interesting. And so thank you. Questions and comments?
Thanks, Manuel.